Recently, I read about NASA investing into warp drive concept known from Star Trek. First, I thought that this is a joke, but no. NASA scientists now think that the famous warp drive concept is a realistic possibility, and that in the far future humans could regularly travel faster than the speed of light.
I'm one of those proverbial rocket scientists that I've dealt with such edgy topics as gravity control space drives and faster than light travel.
Throttle back! Take us out of one!
In this first episode, we are going to find out why we need new technologies to reach stars and planets light years away. Interstellar distances are so astronomical that it is difficult to convey this expanse. Consider the following analogy. If the Sun were the size of a typical 1/2-inch diameter marble, the distance from the Sun to the Earth, called an astronomical unit or AU, would be about 4 feet. On this scale, the closest neighboring star is about 200 miles away. That is about the distance from Cleveland to Cincinnati. At 55 miles per hour, for example, it would take over 50 million years to get there. The Voyager spacecraft left the solar system at 37,000 miles per hour. At that speed, it would take Voyager 80,000 years to reach Proxima Centauri, which is the closest star. But not only speed is a problem, the required rocket propellant is one too. On this image you can see 4 examples of what it would take to send a canister about the size of a shuttle payload, or a school bus, past our nearest neighboring star. And allowing 900 years for it to make this journey. Well, if you use chemical engines like those that are on the shuttle, sorry, there is not enough mass in the universe to supply the rocket propellant you would need. So let us step up to next possibilities. Nuclear rockets with a predicted performance that is 10 to 20 times better. It is still not looking all that good. For a fission rocket you would need 1 billion supertanker-sized propellant tanks to get you there, and even with fusion rockets you would still need 1,000 supertankers. In conclusion, we would really like to have a form of propulsion that does not need any propellant. This implies the need to find some way to modify gravitational or inertial forces, or to find some means to push against the very structure of space-time itself. The third big challenge is energy. Even if we had a non-rocket space drive that could convert energy directly into motion without propellant, it would still require a lot of energy. Sending a shuttle-sized vehicle on a 50-year one-way trip to visit our nearest neighboring star would take an energy equivalent to what the space shuttle's engines would use if they ran continuously for the same duration of 50 years. To overcome this difficulty, we need either a breakthrough where we can take advantage of the energy in the space vacuum, a breakthrough in energy production physics, or a breakthrough where the laws of kinetic energy do not apply. In our next episode, we are looking at some ideas on how we could achieve interstellar journeys in the future.